All right, good morning. This is Mr. Solid. This is active physics. And what I'm going to do today is go over the projectile motion equations, and you'll have some problems to do for the remainder of today, Thursday, November 12th, and tomorrow, Friday, November 13th. For those of you that are fully remote and have been remote the last couple of weeks, everybody is remote starting Monday. And the expectation is that you are logging in every day at 11 a.m. for the Zoom meetings and to check in for attendance. And we are also starting a new unit on Monday that we'll roll with for the next couple of weeks with work, power, and energy. All right, so let's get at the projectile motion equations. All right, so anything that is projected, a projectile, is going to have both vertical and horizontal components. So again, vertical, looking at that direction, horizontal, going in that direction. So the X and the Y directions. Gravity affects the vertical motion. Remember, anything that's falling is actually being attracted to the earth by gravity. And again, we already have and worked with this value here. So acceleration of gravity, 9.8 meters per second squared. The vertical speed of the ball is going to increase, or say a ball being thrown from a height is going to be 9.8 meters per second after each second. Right, so after the first seconds pass, this is the vertical speed now, will be 9.8. And then after the second, it doubles, right? If you double 9.8, you get, so that's the vertical speed. Remember, the acceleration due to gravity is always 9.8 meters per second squared. So the acceleration of gravity affects only the horizontal component. I'm sorry, the vertical component. The horizontal motion is not. So again, an object that's going in this direction is not affected by gravity. So if we neglect the friction from air, so we're setting a parameter here, when we throw an object horizontally, its initial horizontal speed will not change. For example, if you threw a marble horizontally at a speed of 5 meters per second, the marble will be 5 meters horizontally from our hand after 1 second, 10 meters after 2 seconds, and so on. All right, so those are some of the parameters. Now let's look at solving and looking at the only 3 equations you would need. So again, solving projectile motion problems requires using 3 equations, and these are simplified versions of some larger equations because we're going to take some liberties and eliminate some of the variables. So here's some of the steps. Obviously, you want to read the problem carefully. If you want to draw a diagram, that's fine, but also you should be listing out, again, everything that's given to you in the problem. So again, listing what you know, and then finding out what you're solving for. And again, you put that question mark next to that, what you're being asked to solve. Again, and then you've got to come here and look at, based on what you're given, which of these 3 equations you're going to use. So you may need more than one equation to solve the problem. So you might need to solve one part to get a missing piece, and then you use that missing piece to ultimately solve for what the problem's asking you. So if you're looking, say if you're looking to solve for the distance an object has been, projected, so your distance, here's your equation, in the x direction would equal the velocity in the x direction times time. So again, this is just a rearranged version of your original speed equation we worked with at the beginning of the year. So the velocity in the x direction should be read as the initial velocity in the x direction. All right, so that's horizontal distance. So these next two now you can solve for vertical conditions. So vertical velocity would be the velocity in the y direction, and that would be gravity, the acceleration due to gravity times time. And then say if you're looking or trying to find the vertical distance, or sometimes they use the word height. So that would be the distance in the y direction again, and that would be 4.9 times squared. So again, gravity is included in these equations because the vertical speed accelerates due to gravity when an object is falling. So notice that, again, you've got g here, and really this is half of g, so g is included there. But when you're talking horizontally, there is no acceleration due to gravity there. And then, again, these are some assumptions that are being made. The equations above are suitable only for situations where the projectile starts with 0 vertical velocity, like a ball rolling off a table. If the projectile is launched up or down at an angle, the equations are... What just happened? All right, hold on 1 second here. All right, I apologize, I lost the worksheet for a minute, but we're back. All right, so if you now scroll down to page 3, what you do is you have an example problem there that you can go through on your own. What you also have for number 1 is how I'm expecting you to solve the problems. So a cat runs and jumps from one rooftop to another, that's 5 meters away and 3 meters below. Calculate the minimum horizontal speed with which the cat must jump off the first roof in order to make it to the other. So again, what you can see here is that I went ahead and I just drew an image, right? You've got two rooftops that are separated by 5 meters. One is 3 meters below the other, right? So that just helps me visually. So again, what do you know? Well, you know the distance in the x direction is 5 meters. What do you need to solve for? You need to solve for the velocity in the x direction. So again, it's looking for the minimum horizontal speed. So what equation are you going to use? Well, you're missing some information. So what you have to do in order to solve for time, because remember, the only equation you have for the velocity in the horizontal direction is this first one, d of x equals v of x times t. So what? All right, apologize again. But again, this is ultimately what you need to solve for. You need to solve for that v of x. But you don't have time. So what you have to do is you have to solve for time. Since you know uh, the distance in the y direction, which is going to be that 3 meters, you just rework this equation to solve for time. And that's what I did over here. And you wind up with the time of 0.78 seconds. Now, since you're solving for this, this would make this equation v of x equals d of x over time, and then you just plug in your value. So again, your distance in the x direction was 5 meters, and you calculated for time. So then your velocity winds up being 64 meters. Actually, I'm sorry, that's 6.4 meters per second. So that's what you can see here in this example here. All right. So since this one actually had the two equations, I'm just going to have you go ahead and complete problems 2. 3, 4, 5, and 6. So that's 5 problems. And if you choose to do 7, I'll consider that extra credit. All right, so that's the assignment for Thursday and Friday. Those of you at home, just complete it in Cami and send it to me no later than tomorrow at 3 o'clock. And remember, you need to check in daily starting next week at 11 a.m. All right, have a good weekend, and we will see you Zooming on Monday.